Morena tato, haere mai. Now mai kitera erua on NZRSE 2023. Good morning and welcome to day 2 of NZRSE 2023. I'm Nisha, the training lead at NeSI, and it's my pleasure to begin the final day of NZRSE conference where we have an exciting day of presentations and talks lined up for you. We will begin our day with our keynote speaker, Dr. Bing Xu, who would speak to us from 9:40 today. But before that, I do want to reiterate a few housekeeping rules to make sure that we all make the best use of this online platform. To ensure a smooth and enjoyable experience for all of you attending this conference, we have a code of conduct in place. Do visit our conference website to read more about that. If you're having any sort of technical issues, you can click on the red live support button on your screen at any time. I'd also like to point out that recordings of all the previous sessions from yesterday and today will be accessible within the eVentShare platform after the conference is over today. Don't worry if you've missed an interesting talk, you would get access to a recording for sure. Finally, I do want to take a minute to remind you that you can chat with other attendees and presenters using the Meeting Hub option, which you can access on the right-hand side panel of your timeline. If you have any further questions, please pop those into the live Q&A box now. I will wait for a minute to check if there are any questions popping through. Does not seem like it. Okay, we're good to go then. And thank you again for being here. And I'll see you all at 9:40 when we welcome Professor Bing for the keynote presentation of the day. Thank you. So, I'd like to welcome our keynote speaker, Professor Bing Shui, who will be talking to us about artificial intelligence for responsible research and applications. Professor Shu is currently a professor of artificial intelligence, deputy head of school for engineering and computer science, deputy director of Center for Data Science and Artificial Intelligence at Victoria University of Wellington. Her research focuses mainly on artificial intelligence, evolutionary computation, and machine learning, such as feature selection, evolutionary deep learning, and image analysis, and their real world applications in biology, healthcare, aquaculture, forest, and others. She has over fully refereed 350 publications and has led several prestigious research grants. Professor Shui is currently the editor of IEEE CIS newsletter, chair of IEEE CIS Evolutionary Computation Technical Committee, and chair of IEEE CIS Task Force on Evolutionary Deep Learning and Applications. She also chairs many international conferences, such as General Chair of PRICAI 2025, Conference Chair of IEEE CEC 2024, Proceedings Chair of ACM GECCO 2023, and Panel Chair of CEC 2023. She has also served as an associate editor of several international journals such as IEEE, TEBC, TAI, CIM, TETCI, and ACM Tello. She's also a fellow of Engineering New Zealand. Welcome, Bing. Over to you.
Great. Thank Nisha for the great introduction. Hey everyone, so my name is Bing, as you can hear from Nisha. Today I would like to share some of our work as well as also my view in terms of artificial intelligence for responsible research and applications, with some discussion on in terms of research software development, software engineering. So I don't know, how many of you have worked on or have, I'm sure you have heard of artificial intelligence and AI since in very different ways. I don't know how many of you have actually worked in AI, using AI in your software engineering work and in your research and in your daily life. If you are, I'm a professor of artificial intelligence, and however, if you ask me many years ago what is artificial intelligence and now what is artificial intelligence, I'll probably give you slightly different answers. Probably not only myself, many people who expert in artificial intelligence or knows artificial intelligence will give you probably different answers. So if we're looking at the most people know artificial intelligence using very different ways. You know, when I was like 20 years, when I was like in my during my undergrad study, and you know, whenever everybody talking about artificial intelligence, you know, you talk about robots, right? And if you at the moment, if you just Google artificial intelligence in a Google image, they show you a lot of robots. And back to many years ago, and then people start talking about AlphaGo, and in terms of in 2016-ish. And so everybody knows things. Artificial intelligence knows artificial intelligence because of AlphaGo. And maybe from last year until this year. And when I start talking to the high school students, what they know about is all about ChatGPT. And if you technically know artificial intelligence, a bit more technical details, you know, people start talking about, you know, what is AI? So AI is deep learning, and deep learning is deep neural networks, or AI is deep neural networks. So there's many different views in terms of what is AI. So we probably cannot come up with an agreed definition on what is AI, but we probably can looking at what the features of AI. You know, in general, there are only two words, right? There's artificial and intelligence. So it has to be artificial is not a human. Intelligent, it has to be similar or like a human. And it do kind of not only think or sense like a human, but also need to do some actions. And in a group of artificial intelligence AI group at Victoria University of Wellington, so we had many discussions. We're looking at many references from, you know, as early as the 1940s until these days. We summarize artificial intelligence in a way that, you know, AI is a science and engineering of making intelligent machines. So those intelligent machines have to be able to act, learn, sense from the experience, and perform tasks for humans. So that means that that's covering artificial, covering intelligence, covering think, and covering act. So that's what we come up with the key ideas of artificial intelligence. And if you're looking at our website in our university, you see this definition, this description as well. And then if we look more, and not only artificial intelligence, the research group, now we have expanded the AI group to an AI center. We have a data science and AI center. So the knowledge and discussions within here, and also the representatives of the group or the center, and it is involved in the different sectors of New Zealand in terms of research, applications, and government and the industry. So here is a group of the people. So we have a Center for Data Science and AI. So we probably can claim it's the largest data science team in New Zealand, and also the largest team with evolutionary computation, evolution learning folks in the Southern Hemisphere. So here are the people that in our team, and in terms of the vision, what we have in the research center. So it's basically covering research excellence and innovation in a sustainable data science and AI. So that is quite similar to what we talk about. The theme of the conference this year is about responsible research software. So in practice, in covering, you know, sustainable, responsible, reproducibility, as well as ethical considerations. So what we have there is basically the key is fundamental research and innovative method, as well as key applications. So those parts, of course, need to have a real impact to New Zealand and to the world, right? So that significant impact to economic, social, environment, and health outcomes. As well as, as we sitting at the university, the training of postdoc staff, and also their students at different levels, as well as a particular focus on the Maori Pacific student. That's also part of our vision. In terms of the key technologies, and you can see we have 6 technical themes. That's where we are good at. And that will cover all the major, all the popular, most widely used techniques in AI and data science. But I have to say that everything related here, and that's all supported by the research software development. And then, so the key application areas, while looking at the theme of the conference this year, as well as looking at our visions and our capabilities, application domains, they're somehow all related to responsible research. That means we need to have the impact in the real world in terms of climate change, environment, and the social public policies and ethics. That is closely related to what the theme of the conference this year. I feel like this is also somehow the trend of not only software engineering, AI, data science, kind of many different research that kind of have the service and tools, and all need to cover all those kind of responsible research. So those are the research, and I always like to say AI is everywhere, and I probably should also, I also agree that software engineering is also everywhere. And in terms of real applications that impact also to benefit or risk or work or life, probably software engineering started earlier than AI and have been playing actual impact, probably more in AI in different ways. So all these AI related applications or tools somehow all built on using software engineering or software development skills that have to put into to become a reality. And if I'm looking at AI everywhere, AI, and then you probably can say AI, there's a lot of AI applications that's related to software engineering. And if I looking at have a quick search in the click up in the database, you can see that there are many AI applications, apps. That's probably most of them are the startups. And if you're looking at here, say coding, documentation, data analysis, and animation. So those are all, and you probably know better than me, those are all the key part of doing software engineering, right? And then if we're looking at, for example, coding is quite common using AI. In many years, there are coding or generating test cases for debugging. There are also search-based software engineering that is based on AI techniques to search. One of them is basically to search for to find out the best test cases for debugging. And there's a lot, of course, there's a lot more, right? In terms of coding, so there are AI tools that translate natural language to SQL queries using AI, and also AI tools to do the online coding environment, as well as AI platforms that help us to convert from the design to the code. Of course, they have coding automatic completion of the coding. So that's coding. There's having a lot there, and also there will be some others in terms of analyzing data analysis. That's kind of in the planning of the software development. So data analysis in a many different ways. For example, if so there are many AI tools that help us to analyze the customer feedback and provide more actionable insight, or to extract knowledge, to extract ideas or patterns, to help us design of the software. And so that is all kind of in the planning part. And also there are some AI tools to get from the raw data, text data, or from sentiment data, to extract what is needed in order for us to do the software design, the software engineering. So data analysis and coding, as well as documentation. I guess documentation has been not only, has been a long time, right? So including that you using AI tools from image to extract information from the documents, and there's a lot of AI method or techniques that you can do. Of course, that's summarizing articles. This is probably more related to research software engineering. So in that part, that you can summarize long articles, and also to create documentations, to summarize, to extract key information from the document, and also is to just condense, avoid reading a long document. There's also a lot of AI tools in terms of automation, the automation for customer service automation, upgrade automation, deployment automation, and probably automation of the automation step. So there's a lot of AI tools. Then you can see what we can find from here, from click up. So that's mostly not, mostly startups. You probably only see GitHub as one of the big company. But most of this is just a small proportions of AI applications, AI tools related to the software engineering. There are the big ones, big tech giant companies like Google, ChatGPT, of course, and then the Buzz, as well as Canvas. Though for the big giant companies, they are not listed here, but they have developed kind of generic tools or platforms to help the assistant software engineering and development. So basically, I would say that in terms of the whole software development lifecycle, AI is kind of already involved in everywhere. In terms of from the planning stage, including the analysis of the data, trying to find out generating the generation of the software story generation, and as well as find out requirement analysis and the generation project management, and also scheduling. There's a lot, and of course debugging, coding, testing, as well as in terms of a design phase, designs documentation with assessed, and also the flowchart. You can generate flowchart using AI tools, as well as use a design assistant. There's probably also a lot more, and basically, if you are doing software engineering, you are in software engineer, and I myself more like an AI expert. So you probably know even more than me, and this chart is basically from this blog, this website. You could have a look. So basically, the whole idea is AI has been basically involved or being used in every major step of the software development lifecycle. And if we're looking at more AI in the research software development, I think as doing AI research and also doing AI research-based applications, we use a lot of softwares. I think we benefit hugely from in many different ways in terms using the software. And if we're looking at how AI in the research software development, I guess one of the first one would be the use of AI in the data, AI-driven data analysis. So instead of we doing a lot of pre-processing manually or using the traditional statistical method, which works well. But when it comes to the massive, large data set, it's really hard So then we can write script, but the script will not be able to learn to discover hidden patterns from the data. So then where does it come from? These AI tools can be used to automatically analyze the massive amount of data to extract patterns from there. And that can help us to design the later stage. So as well as enhance the simulation capabilities. Simulation is a key, really important in our research, and of course in real world as well. But a lot of research tools or developed including software engineering, including AI, are actually more via simulation. So we don't have, either because of the cost, in terms of financial costs, or in terms of the feasibility of doing the real experiment. So we do a lot of simulation. So with AI, we can kind of can speed up the simulation, can predict more realistic outcomes, like in a real time fashion. And so then, for example, quite a lot of use of the recent use of in terms of AI in the bio or genomics, protein and molecular simulation. So they're using AlphaFold that's doing really, really well. And of course, there will be optimization of the research, the code. And there's a lot of tools for simplifying the code, to optimize the code, even to parallel tasks that you don't need automatically without human intervention. So the AI tools. So there's a lot of potential there as well. The last, but we have kind of touched that is in terms of documentation. So there's so many literature, so many new research published every day. So then we can't read all of them. Then you automate the literature review and to summarize summarize what is the most important one, what's the new advances in that particular area. So that is super important as well. So then in this case, if we're looking at, I would say there's a lot many other areas that where the AI can be used in research software development. And if we come back to the topics of responsible I have a fire alarm here.
Evacuate the building using the nearest fire exit.
Oh, sorry, Bing. We had a fire alarm going off in her office. So what we can do is we can basically wait for Professor Shui to come back, and we can take our break right now, a little early, and hope that the fire alarm situation is over and done with. So let's come back at 10:30. Let's reconvene at 10:30 after our break, and hope that Professor Shui can join us again. Thank you. See you all back at 10:30. You're welcome. I hope everyone got a chance to grab a beverage and relax due to the unexpected break that we just had. But thank you so much for accommodating. We have Professor Shue back, which is wonderful. Thank you so much for joining us. And I'll hand it over to Professor Shue now and allow her to finish up with the keynote.
Yeah. Thanks, Nisha, and thanks everybody for being flexible with these unexpected situations. And the good news is probably the fire alarm is not a real one; it's an artificial one. So it's a testing. So let's come back to where we were. So we talk about the AI in the research software development. And so in research software engineering, you probably have a lot of experiences as well. And so mainly, I would say those a few areas. These areas are where we can see intensive use of AI for research software development. But there are many other areas, really. There's either under development or on the new technologies and being testing, being development, and being in the future. There's a lot more. I'm pretty confident on this part. And then, when we're talking about responsible research software practice, and also, in the using of AI and the impact of AI. So there's also, responsible AI. So which is also a very popular hot topic in this year. I kind of feels like, whatever applies to responsible research software practice and also apply to responsible AI. So this kind of interconnected. You share the similar things, similar ideas, and there are similar concerns as well. So for me, if I'm looking at responsible AI, so there's many. If you again, in terms of AI, there are many different things that you're talking about the definition of AI and other stuff of AI. They always there will be different definitions, different scopes, and people define their own way. But the key idea are kind of almost the same. The key ideas, they all involve ethics and also involve transparency, sustainability, as well reproducibility. And in the recent years, there has been a lot of discussions in terms of ethics in AI. And so, working at the university, we develop many of the teaching programs. We do a lot of research. Ethics can becoming more and more important in the research, and also we have. If you're looking at the big AI conferences. All the research paper submissions now have to have an acknowledgement in terms of ethical considerations. And the idea is not new, but the implementation of the ethical considerations nowadays is become real. I would say real in research. A lot of restrictions in terms of what can be done and what cannot be done in AI. I guess that will also applicable to this software. Research software development. And if we're looking at the reproducibility, so this is also a key topic in both AI and software engineering. So in the software engineering world, you probably know better than me, or much better than me. And so what I can think about, in terms of what can be regenerated in the software. In AI, that would be the same. So nowadays all of our, if you're doing AI research in previous year, let's say back to 5-10 years ago, so you see a lot of new AI models being built, putting online, achieving really good performance. But not majority, but many of them, if you're doing it yourself, using their same code, using whatever they put it there, you very likely not be able to reproduce their results. Some of them could be someday in the hardware configurations, and some of them could be just itself is in terms of AI technique. Many of them actually you can every time you run the algorithm once and run the algorithm another time, you might get a different results. So there have been a big issues in the AI field as well. And nowadays, ethical considerations, reproducibility kind of is a box to tick in whatever research you do and whatever publication you want to have in the AI research area as well. So there's another thing I just want to talk about is the explainable AI. When we talk about ethical issues and many of the things, we cannot ignore all. I kind of feel, in my view, that's all kind of connected to explainable AI. So if so when we're talking about the biases in the software, AI tools being biased, being racist, and without looking at the details of what exactly had happened leading to the particular bias, so we'll not be able to fix the problem. So that what talking about is the explainable AI. For example, we discovered that the facial, one of the kind of commonly used stories, the facial recognition softwares kind of rate the black male have a higher probability being involved in a criminal than a white female. So that is because the data set itself was biased. So with the biased data, you'll not be able to do any you're not going to get unbiased results. So that is really difficult. And then, those are all, I would say, if you want to address a lot of problems with ethicals, with reproducibility and those stuff, you probably also need to know how the AI model comes up to a certain results. So that's part of the explainable AI that what we want to just give you some examples that we have been working on or we have been doing with the research here. So in the past, we were in the past 10 years. In the past 10 years, the AI models, or we saw the deep learning models becoming deeper and deeper and deeper, right? And so, of course, it's becoming more and more powerful. So we have a lot of training data. We feed to AI model, let's say neural networks, and with many layers and a huge number of parameters, we come up with a solution with a model predictability. For example, if you have an input as a cat, and you have a probability, okay, give you a 93%, this is a cat. But you have no idea how the model come up with this particular solution and particular answer. What if you change the cat? What if you change the cat, to an image of a wolf with a different background, or you change the background and change the color? What does the model give you the solution? So that basically there is no understanding of what's going on there. Then you have no understanding. You have no insurance in terms of any transparency, reproducibility, and also many different things. So that is really difficult. And even these days, I kind of feel that many of us, majority of us, has been using ChatGPT, right? And ChatGPT, how many parameters that it has, right? In terms of in ChatGPT 3.5, the previous version, it has over 170 billion parameters. There's no way no one can understand what's going on. And that's not talking about ChatGPT 4, and that's going to trillions of parameters. And so you have no way to understand what's going on. Then if you don't understand what you can do, you can't trust, you can really use in the critical situations. In the future, what we want is, we have the training data, and we want to have explainable models. And here in the example, we understand why it come up with this solution, this prediction, why it does not, why if we change the part of the data, part of the image, whether it will change a different prediction, and we know at what situations this model can be used, at what situations this model cannot be used or should not be used. When we should trust it and when we should stop it. So I think that's one of the key is the explainable AI models. I want to bring up some of the research that we have been doing in our research center. that's involve somehow the explainable AI. And that, for example, so the key of explainable AI models more are using this it's a tree-based model. I want to, so just an example before I go into the tree-based model is, explainable AI is a very good example here. So if we're looking at this image, whether it's showing a set of images showing, the predicted is a wolf and a husky, what the model can give to you. And from the top, if you train a very deep neural networks, or you have a pre-trained deep neural model from large image net, and you are very likely to get a very good performance, right? The predicted is the same as the true image. But if we're looking at, we're doing a change of the image, then you can see that some of them are still doing a good job, and some of them not. It's doing the wrong prediction. And if we're looking into what exactly the model is doing, rather than looking at the object, it's looking at the background. And now you come back to see if there is a snow background, it will be predicted as a wolf, right? And otherwise it will predict a husky. So actually the AI model is not working on the actual object, it's working on something that's not important. So then it's very fragile. So it doesn't, or I don't think anyone can actually trust the result here. So then there's no responsible AI, a responsible development based on such results. So what we want, we have some discussion or some research in terms of a tree-based model, in terms of over the neural networks and large network-based model. So the key idea is, when you're doing a tree-based model, you kind of allow, you still can have a large tree as a model, but the idea you will be able to kind of cut following your decision-making process from input as a leaf node of the tree, and going to each branches and looking at what exactly it is doing. So basically the key idea is, so the complicated decision-making process can be decomposed to branches of the tree, or we see some models, so that we know what's going on. For example, here is just a facial expression classification. So whether it's a surprise or it's a happy. So where we're looking at is more looking at the face, doing the eye region, the mouth region. So that's a key part where we telling the expression of the face. So and you can see that it's actually the model is looking at the eye regions, the big eye region probably covering the nose, and also the area of the mouth. So that is different from looking at the background of the wolf. So this is the tree-based models. Here, for images related, it's also easy to find out. But sometimes we have other Tableau data or database you can looking at that. It's actually, for example, in this case, there is from the raw data, we can build a very simple tree, and that's using very simple operators and plus. And basically, this is a linear linear combination of 4 different variables in the data set. And then you can see that by using these 4 different variables, you can perfectly separate the blue and the red class. And that basically is a positive and negative if you're doing disease diagnosis. And then in this case, so we will know not only achieve a good performance, but also we will know which variables or which attributes is the most important one. So help us to understand the problem as well, or not only explain. So then if the model here, you see that if it is a biased data and is not representing the real world, and you can also be able to see from here. So it's a counter. If the counter intuition, we will also be able to see why this happens. So that's I think to consider responsible research, and this explainable is an important part. And some of the applications that we have been doing here. So again, the key application areas including this primary industry, climate change, as well as health domain. This, if I'm looking at responsible AI, responsible research, that's all related. Those areas are all related to that. And I have to say that whatever research has been done here, that kind of all have to, the final step always relying on a software tools to make real impact in the world, to be used, for example, reused in the farm, used under the sea. So that's the key part. And then, one of the examples that so is for AI for emergency medical dispatch. For medical emergency dispatch, then you can see that for Wellington is a big problem from where I am. So for Wellington, so there is always kind of a shortage of the dispatching of rules is basically in the Wellington Hospital. You see several big screens and locating where people making the emergency call and record the situation. And there will be an operator, a person there to rank, to give the priority over different calls, different situations, and then manually to send the ambulance, maybe the nearest one, to the person to rescue. And basically, if we're using a very simple AI tools that can get having better than sending the closest ambulance. That is the way of this currently in use. So they improve 50 to 70% of the total benefit. So that's the medical domain. And if we're looking at the wildlife conservation and the AI techniques, can be used to detect birds from the from wild as well. Or for example, Zealandia in Wellington, there's quite many research involved in biology, looking at the diversity, looking at species in the Zealandia region, and then that could be used to using AI tools. But again, of course, they need the software to support as well. So one of the examples that we're using quite a lot is to counting the kaka in the Zealandia area. So kaka kaka is New Zealand, the native bird, and at the moment, I think kaka is recovering pretty well in terms of numbers. And then it's a very interesting thing that every kaka is having a kind of fingerprint in their area. So in this head neck area, so every pattern, shape, texture are different for every bird, every kaka. And then what we can do is we can putting a camera there to take pictures and to looking at for a certain number of days. Then we can look in how many kaka has been flying here. So one way that is to basically to put a using the images cameras here and capture the kaka. We put food here in here, then the kaka comes and we take pictures, and then we distinguish which kaka is which. In terms of the health domain that we currently doing is skin cancer detection. Skin cancer is particularly a problem, let's say, important in New Zealand. If you have seen any of the world map in terms of the skin cancer diagnosis, there is New Zealand is kind of in a really bad dark area. That means that the number of people who have been who are diagnosed with or died because of skin cancer is very high, the rates. And in terms of New Zealand, in the early days there was an average of 300 New Zealanders die of melanoma every year. And what we did there in the research is, again, we're using a tree-based model, rather than just blindly looking at what predict this melanoma or not. We actually be able to see that what regions that the model is looking at. So there's a region detection there. So we'll be able to see which region or what kind of pattern the model is trying to see in order to predict the melanoma is positive or negative. And we also can see that we can match with how the dermatologist are doing the diagnosis of the skin cancer. For example, in that case, one of the diagnosis rules is the ABCD rule. A is asymmetric, B border, C is corner. So then we can looking at the model. We're looking at what the model predicted and where the model looking at, what kind of features it is extracted to make a decision. So we actually be able to match what is in the model and to match with how the dermatologist make the decision. Some others are, not going to lots of details, due to the time constraint we currently have. So the environment and climate change, that's another areas where AI has been used and software has been developed. So that for example, the climate change, the rise, the ash melting, there's a big glacier melting is a big problem and leads to the extreme weather in recent years. And so this is a part of the work, and of course we have there's another work is looking at the Wellington, Singapore, this tree identification. We know that the tree for Wellington, for New Zealand and for Singapore, both are very important due to the large land and the small land size. And so the New Zealand kind of scan using remote sensing image scan one city every 10 years, and the most recent scanning is Wellington region. So what we use is the tree from the Wellington region, and what we detect how much tree crowns are there from the satellite remote sensing images. And we also looking at what species each tree is in the region, in the city region as well as the rural area. So that's something we currently doing. And also in terms of data science or AI for agriculture, this one's taken from Nelson. It's a very beautiful day and very nice mussel farm. And if we're looking at for this image, and for data scientists or AI experts looking at is full of data, and there's lots we can do there, including building models to detect mussel float. You can see that, for example, this part, the nearest float is doing a very good job at the moment, but some others kind of think down because either because some other floats was blown away, or some of them was the muscle is growing too heavy, so it cannot really cannot really support anymore. So means we need to do a lot more work. And here is something that we do, that's to automatically detect the floats during the in the mussel farm, and it could be in a good weather or in a very bad weather. So in both situations, actually doing a very good job. But of course, the further work are still needed in order to fully automating the whole process to save human power in this labor in this mussel farm growing. And some others, of course, seafood in sectors, and you see that we have a lot to. Everybody think that New Zealand seafood should be very cheap, but what we see from supermarkets is not the case, and it's actually not cheaper than many other places. So the main reason is actually the fish was actually captured, and the fish was made to very low value products. For example, the fish we kept to make fish meal again, and fish oil, and overall you see the cost to catching the fish and the total value made from the fish, and actually making the total product value to the wet weight of the fish is only actually $2 per kg. So that means because there's low value products, that means the fish fillet in the supermarket we see is very expensive, right? So if we can change that by looking at the fish compositions in order to using different tools in order to make high value products. If we be able to make high value products, and then we'll be able to increase that the cost can be shared by the high value products. And I was hoping that if we achieve this, we're currently using AI techniques to distinguish the composition of the fish, and trying to determine what kind of fish and at what stage going to what process in order to produce what kind of products to make maximize the benefits. So the cost will be shared between the fillet and also the bioproducts. So this is all the AI, this is the work we're doing. But again, come back to what we want to focusing on this, the previous examples we currently doing still, I would say, still in lab, not in the reality yet. So next step we also need is to kind of having the software to be developed, and in order to put them to the reality. That will be AI, I would say AI for good, not only explainable AI and also ethics and everything we're doing for AI. And if we say, we want to put looking at the opportunities and the risk in terms of AI and research software engineering, there's a lot of, some people will say AI will replace software developers. I totally, I strongly disagree. I never think AI can replace any human, anyone in the real world. It's in they'll actually create more opportunities. Also, the use of AI in the reality to produce real impact will need the software engineering to support. So that kind of there's opportunities and there's also chances there. And if I look in the AI in software market as a huge space in the future, and if we say in 2025 we may go to 126 millions in terms. And also, if you go to the global software market, in the value goes to in 2030 goes to $850 billion in the AI market. And if we're looking at with AI being heavily involved in software engineering, and I would say there's a lot dramatic change. That means increase the pace of software, and we're doing that. I would say there's an interdiscipline that we need to learn from both domains, software engineering, as well as the AI technique. So I would say lifelong learning is a very popular term at the moment in AI, and always say we have lifelong learning, and all the fundamentals are always matters. AI can actually replace any key or fundamental techniques. If you don't know what you need and what you will be doing, you will not be able to actually, use AI well. So, and also there's a lot involving platform. That means we just keep learning, keep having all the new techniques and things to do. So in terms of, I kind of I'll finish my talk mostly in this page. And, I would just one more point we do, if you're interested in the AI learning, and we have the AI teaching programs at Victoria University of Wellington. So currently we have the only undergraduate major in AI, as well as we were the first to develop a number of postgraduate AI programs in AI. And of course, if you have degree, the conversion masters might be another good choice. We have been preparing doing that based on what we have been doing. So we have a large team and a large number of courses involved. And then industry connections we have, and connection with CRIs, and we also seek for collaborations. I would think what AI techniques and our research software development and many others need to collaborate together for a particular, to make a real impact in the real world. Yes, now I finished my talk, and thanks very much for listening, as well as for being flexible with the time.
Thank you so much, Ping. That was a very, very thought-provoking presentation, keynote speech, and it was also quite a good segue from our last keynote yesterday, which talked about data and biases. So that was wonderful. Thank you so much. I'm being wary of time, but we will take a couple of minutes to answer any questions you might have. So please make use of the live Q&A box at the bottom of your screen and ask any questions or add your comments, and we'll make sure to answer them. Okay, the first one has just come in. This is from Tim, who says, fascinating talk, thanks. Tree-based models look promising for explainability. Do you have any feeling for how often retraining a tree-based model on a new partition of the data recovers a similar tree, that is leaf features and tree topology?
Recovers a similar tree. So that's I have to say a lot. There are some randomness or stochasticity in the data that lead to you may come up with a different tree. Due to a few reasons. Once the algorithm might have a different start, there are some random numbers might be involved. Another reason is the data itself, the features can be similar. You might have multiple features giving you the same information, and that once the tree may pick up with this feature, and next time it pick up another feature or attributes, then you come up with a different tree. And so sometimes we actually recommend you run multiple times with the different starts, and so have a different tree. Then you will be able to see, to understand the data better, understand the problem better, and that also help you to explain the model, explain the data as well.
Thank you so much. Do we have any more questions? If not, thank you so much, Professor Shui, for taking the time and for coming back and doing it for us again. Thank you.
Thank you.
We haven't started the next session, so please don't worry about losing out or missing out on any of that. We will leave this session and go back to session 4 on your timeline and start with the presentations for the day. Thank you so much.